So this was a project that somebody asked me if I knew how to do from one of my other videos. He wanted to stop a motor using a reed switch and then restart it after a time delay. And I didn't know how to do it, but I tried to figure it out about a few different timer relays and tried to figure it out. I couldn't. And somebody that comments on my videos, I asked him if he knew how to do it, and he did. He built a nice circuit. And I wasn't able to duplicate it exactly how he did it. I think maybe I bought the wrong relay, but I did make it work. So here it's technically working, and I did it a couple different ways. You can go watch that video if you want. But he didn't want to do it with Arduino, and I did want to do it with Arduino. I wanted to learn how to use them. And so I just got on YouTube and started doing different classes from YouTube. Some of them are good, some of them are bad. I like the Paul McWhorter series. If you're a beginner, that's a good place to start, I think. And I learned a lot of the basics. But trying to get that circuit to restart with that switch closed, that was the hard part. So you got to know some in-depth programming. And just messing around with it a lot, I couldn't really figure it out. So I thought I'll get on the forum. And I tried the forum. And a lot of people in the forum, they know how to do it, but they'll show you they know how to do it, but they won't explain to you how they did it. At first I was pretty vague about how I asked to make this work. And then after that, when I realized I was being vague, I was very clear. And a lot of people commented that shouldn't have even commented. I don't even know why they were there. And then some people did send like a code. Here, try this code, and I'll show you some examples of the issues I had. So in my industry, the forums are terrible. And there's just a lot of bad information on them. So I try to stay off of them in my industry. And in the Arduino, I don't know, I guess if you know a lot about Arduino, maybe the forums are helpful. In my case, I didn't find them helpful at all. I did figure out a way to make it work, and we'll talk about that here in a minute. So this is just a basic little code here that I can trip a relay with a button. So it's just a starting point to kind of, see how much I can make work. And then you'll see it here. Obviously, there's no timer or anything involved, so. But it triggers the relay. So that's the first part. We want to see if we can get it to stop. This is one of the codes I got from the forum. And so part of the problem is knowing how to load a library. And sometimes the libraries, I can't find them. Like in this case, you can't even find this library, or you can't get them to load and work. And sometimes it's just the versions. Most of the times I figured it's something I'm doing wrong. But this one we weren't able to try to make work. And then here's another one. I'll scroll down here. Let you look at it, and then we'll see how this one functioned. I just set up a test button with a little relay, so it's not hooked up to that circuit, but you can see here that it can trip the relay, but as long as the button is pushed, then it won't reset. So that's the major issue with this circuit. So not a big fan of the forums. And so I figured I still want to make it work. And I thought, what about AI? And I've never even considered using AI for anything. And so I looked at a couple Arduino AIs. I did 2 of them, and they didn't work. I thought, what about chatGPT? Never used that one before, but you hear everybody talk about it. So I downloaded it, typed in what I wanted, and no exaggeration, 20 seconds, it printed out a code. And I loaded that code, and I'm going to show you that next, how that worked. But it worked. So I would do an AI before I would go to a forum. I did some other projects after this one with a little more difficult codes, and the free version of chat wouldn't do it, so I paid for it, and those versions are working out pretty well. So going from never considering using AI to I'm kind of a fan of it now. But the downside is, am I ever going to learn how to write Arduino code? Now I've got the code, I can study it, I know what the right way is, but if this thing prints these things out, in 30 seconds or 90 seconds, are you really going to go and put the effort into learning how to do the code? That's, my dilemma for the future. Right now, I think it works great, so that's what I'm using. So here's the code it wrote for me. I'll just scroll down in case you want to look at it. If I remember right, this one worked the first time I used it. Some other codes I've used the AI, they didn't, but you can refine them and eventually figure them out and make them work. And so here's the program working. So you can see it stops, it times out, the magnet's still engaged, but it restarts. So one thing it was doing was that the magnet was going past the reed switch. And I thought, wow, that software is not working fast enough like I want. And I didn't realize, and after a while I went back and looked at the original video, and I was like, oh, this circuit does that also. So it's not the software, it's not the Arduino, it was the motor. The motor doesn't have a brake. And so that's why it continues past the magnet. So then I realized in my industry, we do have a motor that has a built-in brake. And that's what I'm using here now. So you can see that it actually stops right when it reaches the reed switch. So whether that's important or not, I'm not sure. I like it to stop right away. There's another issue that I did learn from the forum, and that's bounce. And so bounce is like when using mechanical switches, it could get a false signal, and it was stopping in between the magnets, which I couldn't get it to reproduce to get it videoed. And so I don't have that, but I did experience it. And there's a couple of ways that you can get around that, and one's with these magnetic Hall sensors. Another thing someone mentioned on the forum, but gave no detail on how to make it work. So here it was pretty basic with the same program, and you can see the Hall effect sensors working. Now you don't have to worry about the mechanical bounce. But there is a way to get around that, I found out, and there's a debounce, I think it's called, that you can put in the software. And this is just another view of showing the Hall effect sensor working. Then I had the AI write me a program with the debounce. So there's a debounce delay, so you don't have to worry about those phantom signals from a mechanical switch. So let's scroll down here and let you look at that code there. Once again, I did experience it, but I couldn't get it on video. I tried over and over and over, and it would work every time. And then this is just an example of that debounce software working. So another thing I discovered in this process is that you have to be aware of how much load the Arduino can handle. And they don't handle very much. You can see here that that relay is 68 milliamps, and the Arduino can handle, I would say 20 is probably safe, but you can see this little paragraph I got off the internet. So 60 is still higher than the 40 they list here, so you want to use a separate power supply. And so I've got in the next clip another power supply powering the relay, but the signal still comes from the Arduino to trip the relay. So here you can see I have a separate power supply, but the circuit's not working as it's supposed to. It's not stopping. And that's because when you're having two power supplies, one from the Arduino and then an external one, I should say, you have to jump the grounds together. So here you can see there's a jumper wire between the ground of both of those. Here's how it was before, no jumper, not working. So once you put the jumper in, then the circuit will work. And this power supply came out of one of the kits I bought. So here's the specs on it. It can handle plenty for what we're trying to do. Another thing when you're using relays, especially with sensitive electronics, you have to worry about this back spike you get from the relay when it de-energizes. And the way they deal with that is with the flyback diode. And so trying to do some research on that, whether I needed one or not. I'm using a relay that's on a little circuit board. And so I couldn't find any information on this exact one. Once again, this came in one of the kits I bought, but you can see there's a diode right there. And looking on the internet, I'm pretty confident that that's a flyback diode on this. So at this point, I'm just prototyping. I'm not doing a permanent project. I'm comfortable using this relay. So I've experienced this spike in real life. It was in a motorhome that had LED lighting throughout. And then they would use one of these touch screens that you have to, which I think is really stupid, especially for turning on the thermostat or the lights. Buttons are way better. But anyways, that's what they were using. And one of the controls was for the electric side of the water heater. And so when you would turn off the water heater, that relay would de-energize and put a spike through the system, and all the lights, LED lights in the motorhome would flash. So speaking with the company that made that product, they explained to me about the diode. And so putting the diode in there cured that. So the lights quit flashing when you turned off the water heater. So I've actually experienced that in real life. And the diode does work. That leads us to my favorite part, where do the wires go? So that's always the funnest part for me, is connecting the wiring. So I have a little 12-volt battery, which goes through a switch so I can start the whole process. And then the other positive side out of that goes to the relay. And then out of the relay, the positive side goes to the motor. And then from the battery, the negative side goes through directly to the motor. So you can see here, in and out through the relay. And then here's just a close-up of the relay. And then to trigger the relay, this is in pin 3, but you program which pin you want it to come out of. And that goes to this signal on that relay. Then we're powering it from this power supply. So your positive and negative are going to that power supply. And then don't forget you need to jumper the two together on the ground side. This is a close-up of the pins, so you can see there's an S, a plus, and a minus on this particular relay. Then for the switch, you're going to have a ground going to one side of the switch and then out of that switch to another pin that's programmable. Then if you're using the Hall effect, these are labeled also. Your ground, your VCC, and then your signal. So you would put that to pin 3 instead of the reed switch. Same program, same software. And it gets powered through the power supply also. Okay, so that's my little journey into the Arduino world. I'm having a lot of fun doing it, and I'm glad I got that project working with the help of some AI. It was kind of fun, so we'll see what we come up with next time, and thanks for watching.